Hey, algebra. Here's our do now for today. We'll split the class in half. Just go ahead and count up the number of letters in your first name. And if you get an odd number, you do number one. If you get an even number, number two. Go ahead and hit pause so you got your answers worked out. And I'll just hang out till you are ready. Nice. All right. Hey, so for number one, we just divide both sides by 8. So x is less than or equal to 3. And number two, we divide both sides by -6. And that is, since we're dividing by a negative number, that's going to make us need to flip that inequality symbol so that it faces the opposite direction. Y is greater than or equal to -4. Okay, today we're taking a look at graphing linear inequalities. This is the last piece to graphing linear inequalities. And we've been doing this for quite a while now. And lots of different types of equations for lines. So our same 3 steps apply. We're going to decide what type of line style to use. Is it dashed or solid? Next, we're going to graph the line. And lastly, we're going to shade on one side of the line or the other. We're going to use a test point to decide where we are supposed to shade on that graph. So today we're going to look at standard form. This is the third type of equation that we're graphing with linear inequalities. Standard form looks like ax plus by equals c, where the a, b, and c are all going to be numbers. So there's an example here, 2x minus 3y equals 12. So standard form, both the x and the y are going to be together on the same side of the equal sign, and then equals, whatever, some number. The way we graph standard form is by finding the 2 intercepts, both the x-intercept and the y-intercept. And the key feature we need to remember about intercepts is no matter where on the graph we're talking, whether it's an x or y, it doesn't matter, there's going to be a 0 as one of the coordinates. So an x-intercept is going to be someplace across the x-axis, some far, left or right, wherever. So it's going to have some number for the x-coordinate. But the y-coordinate, that second number, has to be a 0. Otherwise, our point will be up above that line or down below the axis. The only way to have it be on the x-axis is for that second number to be a 0. Similarly, with the y-intercept, that first coordinate has to be a 0, so we're not moving left or right. We're going to stay right in the middle of the graph and on the y-axis, and then we'll have some number for the y-coordinate. Whether it's up or down, it'll be positive or negative, whatever. So in order to find the intercepts, we're going to take our starting equation or inequality and replace one of the parts of that equation with a 0. So if we're trying to find the x-intercept, we're going to change the y with a 0. Like just erase the letter y, change it into a 0, and that whole term will now turn into a 0. Solve whatever's left to solve for x, and that's the x-intercept. To get the y-intercept, we're going to leave the y part of the equation, but change the x, the letter x in the inequality. We're going to change that to a 0, solve what is left for y, and that will tell us what is the y-intercept. So let's do an example. So 8x minus 6y is less than or equal to 24. All right, so I'm going to pull that equation over here to the side, and to find the x-intercept, I'm going to change the y into a 0. When I multiply the -6 times y, I'm going to get 0. So really that whole term just drops out. So 8x less than or equal to 24. And that is the same thing that some of you just did in the do now. And divide both sides by 8 to find that x is less than or equal to 3. So there's our x-intercept. Let's do the same thing on the y-intercept. We'll just grab another copy of that equation. We're going to change the x into 0 this time. Don't lose track of that little minus sign between there. We need that -6y less than or equal to 24, and that's what the rest of you did for the do now. So divide both sides by -6, and that's going to give us y is greater than or equal to -4. Again, since we're dividing by a negative number as our algebra step, we're going to have to switch the inequality symbol to make it face the opposite direction. So y is greater than or equal to -4. We're not actually going to use that as part of our graphing, but we don't want to make mistakes. We're going to practice solving correctly. So I'm going to put dots on those 2 places on the graph. So just as a reminder, we're not going to combine the 3 and -4. Those don't go together. Those are two separate points on the graph. So I'm going to put a red dot at 3 on the x-axis. There's our x-intercept. And then I'll have to scroll down to get -4 on the y. That is our y-intercept down here at -4. Okay, so I'm going to connect those two dots. That's how I'm going to get my line. Before I draw the line, I need to back up and identify what is the correct line style. So for this inequality symbol, solid or dotted? Nice. Yeah, so I'm going to use a solid line here because it has the or equal to as part of that symbol. So solid line to connect these two dots. So let's go ahead and draw a line from the red dot to the green dot. Go ahead and make this a little bit longer. And then let's change this to arrowheads. All right, so I have the correct line style. I have drawn my line. Last thing I need to do is determine where I should shade. I like to use 0, 0 because it's always easiest. So 0 and 0 is going to be my test point. So I'm going to take those coordinates, put them into the original inequality. If it gives me a true number sentence, what that's telling me is that the point I'm testing is in the correct part of the graph to shade. Right? If it gives me a false number sentence, that doesn't mean I screwed up. It doesn't mean I need to choose a different point. It's just telling me that the location of that test point is in the part where I do not shade. So really what that means is I got to shade the other part of the graph. Okay, well, so let's find out what happens. So I'm going to take another copy of this equation, and this time I will change the x into a 0 and the y into a 0 because that is the test point I chose. And so when I subtract 0 minus 0, I get 0. And I get to ask myself, is this true or not? Is 0 less than or equal to 24? Yeah, it is. So what that means is where the test point is located is the correct part for me to shade. And so since the test point is above the line, I'm going to fill in with some shading that whole top part of the graph. Everywhere that is above that line gets shaded in. All right, let's do one more example here. So 3x minus y is greater than 3. So we're going to find our intercepts again. So I made copies of that equation again so I can work on the two intercepts separately. Let's do the red x-intercept first. I'm going to change the y into a 0, which means I'll have 3x is greater than 3. Divide both sides by 3. So final result, x is greater than 1. That's going to be my x-intercept. And to get the y-intercept over here in green, I'm going to change the x into 0 so that y is left there. So I got negative y greater than 3. And really what's happening in here is there's an invisible 1 right there. So to get the y by itself, I need to divide both sides by -1. Divide both sides by -1. And I'm dividing by a negative number. That inequality symbol is going to flip. So y, and then my inequality symbol faces the opposite direction. And 3 divided by -1 gives me -3. So here's my y-intercept. Okay, let's put those 2 points on the graph. So my red x-intercept is going to go at +1. The green y-intercept, need to scroll a little bit down here at -3. Before I connect them, let's double check what style of line I should be using. So this inequality symbol means a dotted line. Right? It does not have the or equal to, it's just greater than. And so I'm going to use a dotted line. So I got my dotted or dashed line selected here. Connect those 2 dots. Perfect. All right, I'm going to change that to arrowheads on here. And lastly, I'll need to determine where on the graph I need to shade. Again, I would rather use 0, 0 because it'll be the easiest point to test. So let's grab a copy of this equation and use 0, 0 to test. Is that point in the correct part of the graph that I should be shading? So change everything to 0. The 3 times 0 gives me a 0 when I replace the x, and then I subtract 0 minus 0. So here we go. 0 greater than 3. Is that true? No, 0 is not greater than 3. No. Okay, so what that tells me is the side of the graph where the test point is located is not where I should shade. So the test point is above the dotted line, and that's not where I should shade. So what I do need to do is shade the other part of the graph. So from that line I drew, I need to shade below it. Shade, 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 shade. There we go. All right. So in conclusion, there are some other ways that we can use to determine where to shade. I like to use test points because it doesn't matter what type of equation I've got, a test point will always tell me the correct place to shade. And that way I don't have to learn one method for how to shade a standard form equation, a different method for how to shade point slope, and a different method for how to shade slope intercept. You can find some different ways to determine where you should shade. The totally or other approaches. I just like to keep things simple, so we're always going to do this one method instead of having to learn a whole bunch of different approaches for every single type of equation.